All right, welcome back. So I'm going to pick up where I stopped last time with this Model 1 or Module 1 lesson, and that would be past there, right here, setting variables and arithmetic. And again, this is going to be some of the more fundamental things. So if you've already had the class or you're in it right now, you're going to be very exposed to these topics, but it's still something to be aware of and just going to help you overall. So let's just talk about setting variables, right? Just because we had already spoken about what variables are and how we can use them, but now let's talk about actually implementing them in our code. So here we have two main important ideas, which is left versus right side and compatibility. So left versus right side is how we initialize a variable, right? How do we set it in Java? And what I mean by sides is left side of the equal sign and right side of the equal sign. So on the left side, we have int age, and then on the right side, we have 10. So here we have, on the left side, we have two things, right? We have int, which is the data type, as we've spoken about earlier, and age, which is just what I'm calling the variable. On the other side, I have 10, and then finish that up with a semicolon, which is just standard Java notation. So in this case, what I'm saying is when I go to memory and I look for this variable called age, it's going to be holding a value of 10, right? And this is how we set it up. If we want to reset this value, we're not going to be needing this int value anymore, right? If I write int age is equal to 10, and then some lines later I want to change that to age is equal to 15, I just write simply age equal 15 and then end that with a semicolon. There's no need for me to reinitialize it with using int. The second point is this idea of compatibility, which is essentially just making sure that the data type that we declare is the data type that we're giving it. For example, here I have int age is equal to 12.5. Now, in this case, we're going to get an error because what we're saying is, hey, we want to make a variable and we're going to call it age, and we want that age variable to hold ints, aka whole numbers. Now, when Java's like, okay, well, what do you want me to actually store in there? We're giving it 12.5, which is not an int. It's not a whole number. It's a float or a double. You could initialize it in either sense. So this is where you get into some of the pitfalls of coding, right? Just because compatibility, instead of hard coding 12.5, you could ask somebody, hey, what's your age? And they could be like, oh, it's my half birthday. I'm actually 18 and a half, or I'm 12 and 3/4 or something, and they enter an age like that, and then your code's gonna break. So that leaves you with two options. You could either change the int to, for example, double, so it'll say double age is equal to 12.5, which would be fine. Or you could do something called typecasting, which we're going to talk about very soon, actually. Now, the next portion with variables is that we can do math with it, right? Arithmetic. We have normal math, right? Addition, subtraction, division, multiplication. And these four symbols are what we use to do them, right? So we could have variable 1 plus variable 2 and set that equal to a third variable. And, that would work. 2 plus 3 is going to be equal to 5. We also have this thing called modulus, which is pretty cool. Later down the line, I'm going to be including a kind of like a code along with me kind of video, and that's where we'll actually see modulus coming into play. But to kind of break it down to you, I'm just going to open up my other screen over here. Right, cool. And just talk about it, right? So modulus, what it's going to be doing is, let's say I have right here, let me use this white, make it thicker. Cool. Let's say I have 10 divided by 3, right? So if this is just an int value, this is going to return 3, because in reality, 10 divided by 3 is really 10.333 repeating. But because we're storing this as an int, it's going to be rounding down, and it's just going to essentially cross this out. So we're left with 3. Right, but what if I want to know what the remainder is, you know? What if I have 10 divided by 3 and I want the remainder? Well, that's where modulus comes in. 10, and we use the percent symbol to represent mod. 10 mod 3 is going to be equal to 1. Because what happens is we're going to say, okay, 3 divides into 10 evenly 3 times, and it's going to leave us a remainder of 1, which we are going to return back to the user, right? And this could be useful in any kind of sense, maybe you're trying to make some kind of program that's going to, say what kind of bills and coins you should give back to somebody for change, right? Well, you don't want to, if somebody has $25 in change, you don't want to give them all ones, right? So what you're going to do is you're going to say, okay, the $25 divide by, or mod 20, right? And if that value isn't 0, well, we're going to say, okay, well, you know what? We're going to need not just $20 bills, but we're going to need, say, $10 or $5 or $1 bills, So it's something that you could implement for a variety of projects, really. Okay. And we also have additional math, right? Powers, squares, pi as like a variable kind of thing that we can use. But when I say additional, I just mean that they're a part of a different library, right? When I write plus, I don't need to import anything. I don't need to call a different object, none of that. But if I want to do, say, raise something to another power, that's when I need to call things from the inbuilt Java math library. So again, we'll talk about this when I'm actually going through the examples. All right, and then the final thing that we're going to talk about is compound logic, or just logic itself. So we have a few pieces of logic, right? Where our 3 most common ones that you're going to need to know are and, or, and not, right? So to quickly break it down, and means that if you have 2 pieces of like a conditional, right? Which we're going to talk about in the future. But right now, just think of conditionals as like a if thing, right? Like if this is true, then do that, right? So what is true? That's what we need to evaluate, right? So that's where and comes in. So for example, I could say like, if, you're above 10 and you're less than 15, you could get like a free piece of candy at the bank or something, right? So that means that both you need to be above 10, but also less than 15. Both, right? If you're less than 10, that statement is false, you don't get the candy. If you're above 15, you don't get the candy, right? If you want either or, that's where you use or, right? It's like either, you're above 15 or you're less than 10. So if you're 9, you get the candy. If you're 16, you get the candy. If you're 13, you don't get the candy. And then we have not, which is just basically negating that, right? So it's like if you're not 15, if you're not 10, that kind of thing. We also have our common, greater than, less than, equal to, and then again conditionals that I briefly talked about right now. We also have compound logic, which I kind of alluded to in the previous slide, which is basically just, instead of having like a single statement, such as, if this person's age is greater than 10, right? Then do this. You could have some kind of set variable. It's like between this range, not this value, etc., etc. So for example, we have if age is greater than or equal to 12, or if they're less than 18, right? So what logical elements did we use? We used or, we used greater than, we used less than, and then we also used equal to as well. And let's talk about some sample ages that we could include, right? So let's say, for example, if somebody's 10, well, they're not greater than or equal to 12, but they are less than 18. So this evaluates to true. Let's say they're 25. Well, they are greater than or equal to 12, but they're less than 18. But this doesn't really matter just because we have this or, right? So as long as one of these elements is correct, is true, we're good to go. So in this scenario, actually any age is valid. Even negatives really, just because a negative value is less than 18. And then finally, we're going to talk about casting, which I again alluded to earlier. But casting is essentially where we transform one data type to another, right? And so talking about my previous example, if I have int age is equal to 12.5, I could cast that value to from 12.5 to just 12, right? And why would we do this? So certain math, right, will return us a number that's like a really big decimal, and we just want to round it up or round it down. Certain logic, right? Like if I want to compare two ints, well, I'm gonna have to compare two ints, but if I'm given a double, I might need to typecast that. In certain methods, for example, you might be able to write 10 in a string with quotations, but the method only, accepts numbers. So you're gonna have to typecast that into into a number like an int or a double. And we'll get back to casting and all this, especially in a future lecture where we're going to actually code alongside. Um, but this is again just the end of the first module over here, and I hope it helped. Let me know if I can add anything additionally. Thank you.